And today is the first day where we'll dive into the, core aspect of machine learning, where we start discussing about one of the important part of machine learning, which is regression. So this topic with lesson 4, as we can see, it involves, regression, and it involves different part, which is tools of the trade, managing data, linear and polynomial regressions, and logistic regression. So it involves a lot of part that we'll be able to see today. For this session, Sahid and I will cover machine regression. Sahid is also a lecturer at Kaduna State University. And so Sahid and I will cover this. So I will quickly cover this introduction of, what we'll be seeing, and Sahid will continue with the stuff. So we can see here in this week, lesson 4, we'll discuss the tools, like how to do installation. This data, linear, logistic regression. Hopefully we'll be able to cover today tools and data. And in our next meeting, we can cover linear and logistic. So before we move on, machine learning. So we are doing machine learning. We already know what is machine learning, right? Ability to give it, to learn automatically without being programmed. Ability to learn without being explicitly being programmed, right? So what does that mean is that given data, we'll be able to predict that this person has a particular disease. You can see we do not program, but we just give algorithm a data, and the algorithm will be able to learn some patterns in the data and be able to do prediction. So we can see machine learning in some ways. There is notion of prediction, right? So, but machine learning is divided into different categories. So at the basic level, there are many stuff, but just assume we have supervised learning, unsupervised learning, and reinforcement learning. These are some of the bases, for machine learning. But what we'll be seeing, I think, for the whole this, course, we'll be seeing supervised learning. I'm not sure, maybe, yeah, we have unsupervised clustering, but today we'll be seeing supervised learning. So what does that mean by supervised? So, and inside the supervised learning, it divided into two. We have what is called classification, and we have what is called regression. So you can see in supervised learning, you have classification and regression. And inside classification, there are many algorithms. Can you see naive Bayes, support vector machine, K-nearest neighborhood distribution tree, neural network? All these ones are algorithms to do classification. Inside regression, we have many things: generalized linear method, logistic regression. But also you can see we have support vector machine, then we have support vector machine, meaning support vector algorithm can do classification, can do regression. We have ensemble method. So what I'm trying to do is say here is that we do have, we do have a lot of algorithms that can do either classification or regression, but some algorithm can do both, meaning they can do classification and they can do regression, while others can do only one, whether classification or regression. But let's look at what does that mean by supervised learning? So what is the meaning of supervised learning? So supervised learning is something that you are supervised. So for example, let me give you an example. We have student in class, and we teach this student how to write 1 plus 1 is, they say, is 2. Okay, 2 plus 2, they say, is 4. You can see we are teaching them, we supervise them, we give them answer. Now, when you want to predict, you just tell them, don't give them the answer. You just, so when you are teaching, for example, primary school, you say 1 plus 1, you put the answer is 2. 2 plus 2, you say is 4. 3 plus 3, you say is 6. So a question and the answer, right? That is supervised. You are supervised, you are teaching them. But when you want to do exams to this student, you just come and say 3 plus 1. You don't put the answer. You want them to predict the answer, right? This is the architect. This is just the setting of supervised learning. That is, while you are training, you give both the question and the answer. When you want to do a prediction, you only give the question with no answer. So this is an example. You have an input, which is an apple, and you annotate this. That is, you say this is apple, and you give it to the model. You annotate, you annotate each instance. You say this is apple, this is apple, this is apple, and you give it to the model. The model will learn, oh, these are apple. When you give it a new something apple, it will predict this is apple. When you give it a banana, it will say it's not an apple. It's not an apple, right? But it didn't even know banana, but it say it will not apple, but it can learn. So this is the basis of supervised machine learning. That is, it learned from training data. And under supervised learning, under supervised machine learning, we have what we call classification and regression. So classification is given data point to classify data, to classify data like this. This is one part, this is another. So for example, I'm given a tweet. I can ask you to classify a tweet whether it is negative or positive. So this is just kind of classifying. So maybe these are all positive, these are all negative. So this is called classification. But we can also do regression. So regression is trying to, predict a perfect line, a relationship between 2 points. So this is basically what we call supervised machine learning. So in supervised machine learning, you are given a data, and that data is leveled. What I mean by it's leveled is this. Assume I want to train machine learning model in supervised setting. Before I train that machine learning model to classify either a tweet is positive or negative, I must prepare a data tweet, and I must level this tweet. If this tweet is positive, I will say this is positive. If this is negative, I say this is negative. So I must have my data with leveled. Now I push the data to train, to model, to learn. So the machine learning model will learn what is positive, what is negative. So when it sees a new tweet that is not leveled, it will be able to tell this is positive or this is negative. So this is called supervised machine learning. Any question about supervised machine learning? Oh, it's confusing. Any question? Please feel free to ask question if you don't understand.
Yes, please explain again.
Oh, okay, cool. So if you don't understand this, it will be difficult to understand. So so what I'm saying is this: supervised machine learning is this. We want to train model to learn pattern from data. We want to train model to learn patterns from data. Now, in supervised machine learning, before we give it to the model, that data must be leveled. That data must be leveled. What does that mean? If you want to train a machine learning model to classify a tweet as positive or negative, you don't put the you don't send the data to the model just tweets, tweet 1, tweet 2, tweet. No. What you need to do, you need to send to the model the tweet and it is level. If a tweet is positive, you say this is positive. If it is negative, you say this is negative. Then you send to the model. Then you are teaching the model. Do you understand what I'm saying? You are teaching the model to learn what is positive, what is negative. You are teaching it. When you finish teaching it, that is what we call training machine learning model. That is, you give it some data which is annotated, what is possible, then you train the model, that is its learning. After it finished learning, then you come and bring it a new tweet, which is not leveled. You didn't even give it whether it is positive or negative, but while training, before training, you train your model with data that is positive and negative. Then the model now has an idea what is positive or negative. The model will learn automatically from the pattern. So now when you give it a new tweet, which is on level, it will be able to predict. So this is called the prediction, that whether it is this. But unsupervised learning, it is not. So you can see here in supervised learning, we are doing what we call prediction. We predict. But unsupervised learning, our data is not leveled. For example, this is input data. You can see, I don't know this. In unsupervised, you just give the data without level. You just give it to the model. What the model will do is just to do what we call clustering. It will cluster something that are related together. That is unsupervised. In unsupervised learning, what we are doing is we are doing some kind of clustering. So for example, you can see raw data, no levels. Can you see? No levels. We don't give it level. We just, put the data to train machine learning model, to train algorithm, and now it will learn some pattern and, group things together. That is unsupervised. You can see unsupervised learning, what it's doing is clustering, is putting some stuff, relate with similar features. But in supervised learning, we are doing what we call prediction. So here, that's why we say the main goal in supervised learning is to learn a model from level training data that allow us to make prediction about the unseen future data. So this is level training data to make a prediction on unseen future data, to predict whether this is Apple or not. But this one is level. Supervised learning is the process of modeling the relationship between data input and the level. I don't know who Angani. What is the difference between unsupervised and supervised? Babangé, do you understand?
Yeah, Angani.
Right. Please, if you don't understand, let me know. So you can see in supervised learning, we know the right answer. That is the level or target beforehand when we train the model. So you can see in supervised learning, we know the right answer because this is input, we annotated it. Meaning we annotate means we said, this is Apple. We put it, we said, this is Apple, then we give it to the model. But in unsupervised learning, we don't, annotate the data. In unsupervised learning, however, we are dealing with all-level data or data of unknown structure. And yeah, so this is just what we mean by, so in summary, supervised learning, we need level data, which make life easy for algorithm to learn to predict. It make easy for algorithm to output the input. Unsupervised use inheriting structure and find patterns. So in unsupervised learning, just give the model data. The model will automatically learn some pattern. Okay, the model will automatically, group this together. It's not predicting. Remember, on unsupervised we are not predicting, but we are, clustering some stuff into similar pattern. And semi-supervised, we have another semi-supervised that combines some, notion of supervised and unsupervised, but just leave it for now. Our understanding is our goal is to understand what is supervised and unsupervised. Do we all understand supervised and unsupervised before we move on? Because this is a backbone between supervised machine learning and unsupervised. Supervised machine learning, the aim is to predict, to make prediction. Unsupervised learning, the aim is to, find pattern and do some kind of clustering or whatsoever. And supervised learning, you are dealing with level training data. In unsupervised learning, you are dealing with all level data. You don't need level. These are some of the key differences with supervised and unsupervised. Okay, if there is no question, let's move on. Now we are talking about training data. Okay, some questions. We are dealing with training data. Data set. So in machine learning, so now we'll be seeing here is supervised learning. Supervised learning. So what we'll be seeing from in this maybe in this session and the next is supervised learning, because we will be given data that is level. So you'll be given a data set first. What you need to do before you do machine learning, you need to divide the data into training and testing. Training is something like this, so you put your data, you give it to the model, that you train the model to learn patterns. Testing is this, like, you give the model some data to test it to see whether the model is doing good. We'll understand this. So given a data set, you divide the model into training and test set. But in some situation, we move from not dividing from training and test, we divide the data into training, validation, and testing. We will learn more about this when we divide our data into training and validation and testing, when we divide our data into training and only testing. So, but the main idea is this, that you take away from it is that sometime we only divide our data into training and testing, but sometime we divide the data, this training data, we further divide it into training and validation. I think we will learn this stuff future. Yeah. Okay, so let me show you like an example of basic terminology in machine learning. So this is a data set with 4 columns: sepal length, sepal width, petal length, petal width, class. This is a flower. You can see that. This is called a petal, right? This is, called a sepal in a flower. Now, this is the length and width of the, petal. This is the length and width of the sepal. So you can see sepal length, they record sepal width, they record petal length and petal width. Now, the main aim of this, so this is a data set that has been recorded. The main of this is that you can see we are taking characteristic of, some part of flower. It is sepal length and it's sepal petal, the length and this. And this data is recorded. And when it is recorded, they took many kind of flowers with their different, the different lengths and width of the petal, different lengths and width of the sepal. These flowers are setosa, versicolor, and virginica. So this means that given, sepal length, this is the data, this is the type of flower, setosa, this is setosa. And now this dot means there is many, 1, 2, then they skip, we have 50. Now here we have versicolor and we have virginica. So it means we have three categories of flowers. We have setosa, we have versicolor, we have virginica. And we take different measurement of those flowers. Now, you can see here, one line is information about one flower, right? This kind of one line is what we call, samples information. So we have, this is samples. One line is called sample without taking. But all this information here about all 150, all the information about this flower is called samples. We also call it instances or observations. So in machine learning, these are some of the terms you hear. When you hear somebody tell you the samples data, it is meaning that the observation you have for your data. Instances, all this is called instance. Or when you say in one instance, it means one record for that flower. That is one information about this flower. So one record, it means we have sepal length is this, sepal width is this, petal length is this, petal, and all this record is for one particular flower setosa. And what we call this information, we call them futures. What describe that flower is called future. So you can see sepal length, sepal width, petal length, petal length. All these ones, characteristic of this flower, they are called futures. In machine learning, we call them inputs, attribute, measurement, and dimension. But what is telling us the class is this is called class levels. So these are the futures and these are the class. So you can see them class level, or we call them targets or outcome. Target or outcome, that is the class. Yes, Babangida, go on. Babangida, you raise your hand.
I thought I unmute myself.
Okay.
When we are training the model, we are taking only one sample, right? Not the entire data. Like
so when I'm
doing the assignment.
Oh, okay. I will come to that. We'll come to that. So when we are training a model, this is one sample like this. This is one sample. This is another sample. So when we are training a model, we expect to train a model with large samples. In the examples they have, it just starts showing you what you can do, but they only take one sample. You understand? We'll come to that. But when you are training a model, you maybe train with 1 million samples. With 1 million sample, that is how machine learning model can be able to understand between those samples. Misali yanzu, you want to train, cancer to find, predict a cancer. You cannot take only one person with cancer, train a machine learning model with only one person and to be able to predict any other person, because mutani will have different futures for cancer. You need to take futures, so this kind of, you need to take futures, you need to take observation from many people, like 1 million, 500, 20, 30, 40, 50, 70, and you train machine learning model with all those futures, then machine learning model will be able to understand from different futures, then you can be able to predict another one. So yeah, so these terms are really important. You should be able to understand them. These futures, so let me give us an example when we want to predict, people with, Bacillopia, we want to predict people with cancers. So for example, these are some of the features like then we put yes, yes, no, no. Then if all these features, it means cancer, then we say yes, the cancer. So label in the cancer. It all this one what's label the cancer, no. So all this kind of information, these ones, the AKHOME features in machine learning are input attribute dimension. And the class that we want to predict is called class level, target, or outcome. So these terms, please take them into consideration. You come across them many times. Any question before let me quickly go on? Any question? So training example, this is another term, training example, a row in a table representing the data set. You can see it's called observation, record, instant, or sample. You know, that is training example. Training example one is called training example. One is called training example. So you can see training. What do we mean by training? So what we mean by training, if we are talking about machine learning, is when we give, model, when we give our model data to train it, to learn some pattern, that is what we call training. Model train. We are training the model to learn. That is called training. These are some terms. Futures, abbreviated as X. So what is future? You can see I told you attribute da suke nuna cewa da muke so mu predict him. Kamar misali yanzu when we say somebody has a cancer, then yana da this, and this, then he is cancerous. All these kind of information are called futures. So this is called future, abbreviated as X. In machine learning, we call futures as X, we abbreviate it. Then target, abbreviated as Y. What we want to predict is called target. Can you see class level or target? So all these are futures. Then we have what we want to predict as setosa, then it's called target. So in machine learning, we call this as Y. We abbreviate it. So these are some of the terms you'll be coming to in machine learning. And yeah, before we, okay. So these are some of the, what we'll be seeing if we are doing machine learning. This is it. You'll be given a full data set. You can see a full data set. And now you need to extract futures. That is, 1, 2, 3, 4, 5. You can see we extract futures and the target, what you want to predict. These are futures. This is what you want to predict. And now if you want to train machine learning model, you cannot train with all the data. You need to divide the data. You take what we call train part and the test part. So you need to divide this in some way. You need to divide it. That is, you need to train the model with this data. And now after you train the model with this data, then you test it to see whether it is working with some part of this data. Can you see that? So you can see you start with the complete data. You identify what is your target, what you want to predict, and now you divide it and something. So these are some of the features I want to show us before we dive into the core content in the lessons, which are really important. Any question before we move on? Any question? Okay, so supervised learning, we said regression. So regression, also we already know, is something that we can use to predict, to make prediction. And there are many kind of regression, linear regression, polynomial, logistic, that we can use. But linear regression and polynomial regression we can use for predicting continuous value, continuous meaning like valued 1, 2, 3, but we have what we call logistic regression. Logistic regression is used not for predicting continuous value, but for binary classification. This is something that will confuse you. I think we will discuss it. So you can see logistic regression. There are quite regression at chicken jikinsa. It is not like this that it do prediction of continuous value, but this logistic regression is used for binary classification. So you can see it can, given something like this, it can divide something, and we will learn more about this. I think, we'll learn more about this in the future. So yes, so let's move on. We already learned how to do installation of a scikit-learn. Oh, my time is up. I need to go. Sahid, to continue. Let me quickly finish this guy. So you can see here, I already installed scikit-learn. If you don't install this, is how to install it in your environment. And now here we import libraries. You already know how to import libraries. We import this, and from scikit-learn, we import many things. Number one, we import data set. You remember, if you want to import many things, you can separate them by comma. We import what is called linear model. We import what is called model selection. So here, linear data set is something that we will use a data set from scikit-learn that comes with some data. We will use linear model. So this linear model is something to do logistic regression. So this is something to do prediction using logistics. And this is what we call model selection. We'll see what that means. So this, we are going to use sample of data set called diabetes data set. And this data set is from here. Let's see it. Okay, I already copied it, and you can click on it. When I push this guy, you can see it. Yes, prediction of yes or no is binary. Yes. So here we can see the diabetes data set. It has 42 number of instances, and it has first 10 columns are numeric. Predictive value, we have column 11 is quantitative, and it has something like this. So let's see the data set. This is the data set. You can see it. So you can see this data set. Scikit-learn has, I need to show us this stuff. Scikit-learn. Can you see my screen? Can you see my browser?
Yes,
we can see your screen.
Okay, so you can see scikit-learn. So scikit-learn is something very comprehensive. It contains a lot of stuff. So it has data set, toy data set. So you can see here we have what we call toy data set. So here scikit-learn has some examples of data set that we can use for learning. That is called toy data set. Number one, you can see iris plan data set. You can see diabetes data set. You can see optical recognition data set. You can see, so these are toy wine recognition data set. These are called toy data set that we can use for learning before we grow and start working on our own project. So you can see breast cancer data set. So this is the data set we're going to use here. And how can you load any data set here? All here. So for you to load any data set, what you need to do, for example, you can see load iris or whatever. We need to call this data set load diabetes. You can see load diabetes because this is how to do that, load diabetes. And remember here, from scikit-learn import data sets, I import data sets. So for me to associate, access anything under data set, I need to call data set first. So data set, load data set. And now I have something return y true as data frame. So remember here in Python, when I have these, A, B, I have this 1, 2. When I run this guy in Python, when I call A, what would be A? When I ask A, you can see 1 is returned. When I say B, you can see, 2 is returned. So this is tuple. So tuple is assigned to this value. So one tuple is returned. The first one is, and so here, when we run this guy, this load data set, it will return 2 values, the future and target. Remember, in machine learning, I already explained, when we want to train a machine learning, there are 2 kind of things. The future, these guys, and the target, right? Future, this column, which is this as well, this future, can you see it? And the target, this is future and the target. And when we call this guy, load diabetes return XY is true. I said it as data frame and run this guy. So it will return the future, it will assign future to X. It will return the target, it will assign to Y. So when I click X, you can see it returned the data frame. We have 10 futures, 1, 2, 3, 4, 5, up to 10. Remember this, it says it has 10, first 10 column are numeric predictive values. You can see them, which are these guys. And when I run, I can say X info. This is Python, right? X info, it will tell you the info about the data set, whatsoever, many information. And now when I call Y, you can see it gives me this one. So how many, data do I have? You can see I have, about X. I have about 442 rows, right? 442 rows, right? For the so also Y must be 442, right? So for Y is 442. Yeah, 440. Oh, 441. Why? Because here is 442.
it start counting with 0.
Sorry.
It start counting with 0.
Oh, 0 to 40. Yeah, 0 to 41. And remember here we have this header. You remember this guy? Here we have this header. I think it included it here. I think you can see 0 to 41. And in here you can see the Y we don't have the header. It's always so you can see something like this. Now, we have our futures and we have this. But in scikit-learn here, you can see I said it should return as frame, as data frame. So look at this one here. If you go to scikit-learn, okay. Okay. Data set loading utilities. There are a lot of, so if you come here, data set loading utilities, it will tell you how you load data set. Let me see this guy. Okay, this is another one. Not this guy. Okay. Okay, so let's look at this. If we want, no, I'm not looking for this page. Okay, let me get this guy. Okay, yeah. So when you click on each data set, for example, you can see iris, load derivatives. So when I click load derivatives, it will show you many things. So you can see this is how you load it, load derivatives, return YA as frame and whatsoever. And it's telling you the parameters of this function, return XY, if true, return data and target. Can you see return XY? If it is true, it will return the data and the target. That is why here you can see we say it's true. It return the data, the futures, and the target instead of bunch object. So there is something called a bunch object in Python, but now they are returning this. So just be careful. So here, but you can train your machine learning model in Python using an array. So maybe we can also remove. Here I just show us like it should return as data frame is true. So if you see this one as data frame, if true, the data is pandas data frame, including columns with appropriate types. The targets are pandas data frame or series whatsoever. You can see them here. So here I put it as true, but I can put this guy. I can remove it here, not true, as data frame. So when I run this guy, look at X. So here look at my my data. Why is this? Because when you are training machine learning model, you train them in either array or NumPy array or something like that. So we may not necessarily train them as pandas. This is better. So here you can see I didn't return it as data frame. So here is my X, and you can see here is my shape, like 442 rows and 10 columns. Exactly the same as like this, 442 rows and 10 columns, right? But I don't want 10 columns. I want to select only one column to train, only one. So for example, what I want is I want to select maybe, only this column, this guy, this column, third column. I want to train machine learning. This is just a sample, just to show you a sample. But when you are doing a real machine learning training model, you don't train with one column, but all the features. Or sometimes, there is a way you can drop something. But let's select one column like this. You can see it's 0.61 minus 0.67 and something like that. So this is Python. I believe this some stuff is telling you select all the rows. You can see this is, subsetting in Python. Select all the rows and, new axis. But the second, this is, it starts from 0. That is 0, 1, 2. So it will select this column, the third column. So here you can see we are selecting this guy, 0, this one, and something like that. So here we select it as well. You can see it here. So, and when we print it here, you can see the shape. No. Let me run it again. Okay. So that's why it's good that you listen to you. Oh, no. Oh, okay. Oh yeah, so I want to show you something like this, the explanation here. Here, when I select this one, here I can say explain this code. So you can see, let me show you what it will say. We have used this if, anyway, I already explained it to you. You can, if you have some doubt, I thought that can be useful, but right. Okay, so here you can see now so you can see we select only one column, right? And with one column. So we want to train with only one column as our data. And now when we call this, you can see we have one shape, 44, the rows, how many? 44, and only one column. All right. So any question before we move on? Yeah, that is, yeah, it's confusing. Exactly. The array is confusing, but the data frame format is, I believe we will understand more about it. But what you take away now is that we want to train a machine learning model. And the way we want to train it, we don't want to train with all the data. What we want to do is we want to train the machine learning model with only one column and predict the, to make a prediction of the class. So this is, what we want to do. But you do what you do in training machine learning model. You give the model something as an array. That is why I didn't return a data frame here, but you can do with that data frame. But in the lesson, this is what they did. So that's why I'm following you. In the next couple of lessons, I think we can do something similar to that. So now here you can see I select that column. So this is just selection. So let's quickly skip this one because this is so. But now remember, we need to divide our data into train, test, set, right? So this is it. This guy, remember this guy? You need to divide your data into train, Y train, X test, Y test. Can you see that? After you have your future, you have your target, you need to divide these guys, X train, Y train, and S test, so that you train your machine learning model on this and predict on this guy. So how can we do that? Scikit-learn also come with something that help us to do that, which is this. Let me quickly go, which is this. So you can see model selection, train test split, train test split. So train test split, that is what it's doing. So here you need to provide the X, you need to provide, so here is the futures, here is what? The target, and you need to provide the sample you want to divide. Here 0.33, it means, it means the test size is 0.33. So for example, let me change it to 0.2. So when I change it to 0.2, it means the test size, not this guy, the test size is 20% and the training size is 80. So let me, I hope this is not confusing. So when I say that is 0.2, I mean, if the whole this is 100%, then 0.2 is 20, 0.2 to 20% is test set and 80 is train set. If I said is 0.4 test set, I specify 0.4, it means 40% of the data is used as test set and 60 as training set. That's what does that mean. So you can see here, I specify test set 0.2, and you can specify it whatsoever you like. We'll discuss more about this. So, but this one you can see, this will return four things. The first thing it will return is X train, Y test, Y train, Y test. This must be in this order. So when you run them, they must be in this order: X train, X test, Y train, Y test. They must be in this order. What is returned? So what we are doing in a nutshell, we are dividing the data into something I show you us here. This one. We are doing this in this step. We are dividing the data into something. No, this guy. We are dividing the data into this pattern. We are dividing the data into this. You can see that we are dividing, X train, this is X train, X test, this is X test, Y train, this is Y train, Y test is Y test. So the model will return, this one will return four things. So let's look at this. What is X train? You can see X train, you can see it. X test, we run it, you can see X test, Y train, this is Y train, in array, and Y test, you can see Y test. So that's, what we have. We divide our data. Now, after you split your data, what you need to do is to train your machine learning. So you have complete data to train model, right? We have our training data. So you can see after you have this, Y train, then you feed into machine learning model. You can see you can use training. So now we need to go and do training of our model, right? We need to go and do training of our model with this X train and Y train. Can you see with X train and Y train? X train, Y train. Because what is X train and Y train? These are some futures, and this is the level you are giving it. When you have this future or this future, this future, this future, this future, then you're not the cancer. When you see this future, this future, this future, this future, bashi the cancer. When you see this, you're not the cancer. When you see this, bashi the cancer. When you see this, you're not the cancer. So this is what we call supervised learning. with level. It is level. So each features, all these samples, for an example, is level. Mun gane cewa yana da cancer ko ba shi da cancer whatsoever. So this is supervised learning. And when you train with this, then you test with this. So let's go back and now see how we can train. So for you to train, it's very simple. Scikit-learn come with what we call, linear model. Remember, we import what we call linear model. So from linear model, it has many stuff in it. You import linear regression. So when we go to linear model from scikit-learn and see scikit-learn linear model. Okay, so when we go to scikit-learn to linear model, you can see what is linear model in scikit-learn. It's linear model regression, ordinary least square linear regression. So this is a kind of regression in scikit-learn called ordinary least square. So there are many kind of regression that you can, use, but here we are using a linear ordinary least square regression. That is why it's under here. So here, that is why we call it here. You can see that. Then now here we instantiate a model. So you can see we call linear model, linear regression. This is how we instantiate. Then you have your model. So this is model. So let me click here. So you can see here, this is a model. So when I call this model, you can see it tells me this is a linear regression model, right? It's linear regression model. Now, what we need to do next is to train this model on our data set. So you need to call xtrain, ytrain, and you said this model you instantiate. This is model instantiation. You need to instantiate your model. Model instantiation. So now when you instantiate linear regression, the algorithm for linear regression is now stored here in this model, this object. So when you run this guy, now this object called model is storing some of the parameters, some of the algorithm, mathematical algorithm for linear regression. It's somewhere here, you can see them. Now you need to train your model. We said here for us to train the model, we use this X and Y train to push into my machine learning model. So what you need to do, since you instantiate your linear regression model, is to now give your model X train, Y train. So training is fit. This fit, that is train. We instantiate a model, we select a machine learning model, which is linear regression. We said train. This calling fit, this fitting is called training. Train the model. Train on X train and Y train. So when we train here, so now here we train our model. This step is called model training. Model training. So now here we train our model. And now we want to predict. We want to predict. So we train a model. Let's go back to our sample here. So here, this is it. We train, right? So we train here. We train with X and Y train. Now, how can we make predictions? So we make prediction on X test to predict Y test. We make prediction on X test. When we make prediction on X test, the model will try to predict Y test. Then we need to compare the genuine Y test and the model prediction on X test to see if the model is doing good. So this is what is going on here. You can see that predict. So predict, we have function called predict. So this function called predict, you give it X test, right? So remember here, I said for you to do, you train your model on X train and Y train. That is how you train your model. Now, when you want to predict, you give your model X test to predict Y test. We call it Y pred. You can see that. So here we call the model. You can see here we always call the model because this is we instantiate the model here. We call model. If you want to fit, you say model that fit. If you want to predict, you say model that predict. So now it gives us Y pred. So when we say Y pred, now this is the prediction we have. So you can see Y pred. This is what it gives us. So let's look at this is Y pred. You can see this is Y pred, right? And what is original Y? What is original Y? It's called Y what? Test, right? Y test. So you can see, in prediction here, the first one, it predicts, for example, 144, and the original Y test is, 59. Here it predicts the second one, some value is 64, but the original one is, 94. You can see here we are doing only one variable, right? We are only using one variable, so it one column, one feature, so it will not learn a lot. So here I'm just giving you in the next couple of examples. That is when we do complete training. And now here what we do is, we plot the prediction. So we plot X test, Y test. You can see X test and Y test, and we plot the X test and Y pred to see if our prediction is making good. So you can see here there is no clear, relationship in some way with, because with the target and the prediction, because we use only one, feature to train machine learning, to train the model here. So in the next, examples, you will be able to see a complete example, how you train the model, how you actually, find the model performance and whatsoever. So this is just to get you up to speed on what this is doing. And yeah, any question before we move on? Any question? Any question? Okay, Tanim, go on.
Assalamu alaikum, sir. Yes, sir. So it is after training and prediction of the results, sir. Can we extract the equation?
Can we extract what?
The equation.
Equation.
The function that will be predicting the result for us.
Can we extract what?
The equation that will be predicting the result for us. For example, like f function x is equal to y. Can we have something like that?
Oh, okay. I don't know if I really understand. Okay, so you want to, okay, can you come over?
That yes, equation is not the model, huh? Is it not the model?
It's the model.
Yes.
So you remember here, you are
the function is the model that you use to predict now. That is the function.
Okay.
So like if you are doing linear regression, it's a simple graph function. Linear regression is just a simple function when you are asked to find x and y in the graph.
Yeah.
Exactly. Y is equals to mx plus c. So that is just linear regression.
What that is
the function.
Yeah. What we did here is we are given x. That is x. That is what we take a single column, and now, we train the machine learning model, to predict y. Right. That is what we did, because that is linear regression, linear something like that. I think there is we are avoiding this mathematical concept here because okay, I will share something, you read more. I will share something that you read and learn more about this mathematical stuff. But maybe also in our next sessions we can discuss this more. Yeah, so that it will not be confusing for other people. Mathematics is scary. So yeah, this is just a toy example on all the process of training machine learning model. And I already took all the time. My plan is just to take 30 minutes, and Saeed will do the next, data. You guys, what do you think we should do? Now we have data, linear, logistic. We need to finish it like in the next. What do we plan to do? Saeed, are you here?
Hello, yes, I'm here.
Okay, so I think let me give you, like, people can give us like 10 20 more minutes to go to the next one, so that we can Yana, do our next one then Saeed linear Yanda, okay.
However,
yes, introduction.
I will suggest we just move it to the next session.
Okay.
Yeah.
Okay.
Because we are having a heavy downpour here, and the network can cut off any minute.
So yeah, so what we can do now, I think I give us like a very general intro to machine learning, how to prepare your data, whatsoever. And what we did now, it's just basic example on how we can take one column and, do some kind of addition. If you have any question, please ask. What I can do also to, if you really want to solidify your understanding, I will share, a book where you'll be able to read, you'll be able to read about this machine learning, just this introduction. So if you have more time, you can read along and you will understand more about the machine learning rather than just going through this. So I will share a book for anybody that is really interested in this concept. When you read the book and chapter, you will understand more about this stuff. All right. I think the book is called, this book, what the name of, let me show you. That's what we use in my previous tutorial. Can you remember me the book, name of the book? Can you remind me?
I think machine learning with scikit-learn and Python.
Yeah, machine learning with sklearn and PyTorch.
For PyTorch and sklearn, one of the two they come first.
Machine learning with sklearn. Okay, yeah. So this is a book I will share with you guys. Anybody that is interested in machine learning, while you read this, our tutorial, it's really good. Okay, this is a book, Machine Learning with PyTorch and scikit-learn. Machine learning with PyTorch and scikit-learn. What we'll be doing here is just, telling you whatsoever highlight, the main highlight. But if you want to really, so for example, for some of us that are master's student, the PhD student or whatever, it's quite good to have access to book that you can read on your own to learn more. What we are discussing here is based on, you can leverage more. So I will share this book. It's a really nice book. And yeah, any question? Any question? Okay. Okay, so